Hi everybody, this video is meant to introduce to you the heat treatment process used that you guys are going to be talking about in the heat treatment and hardness lab for AME 324L. Right now I'm going to be introducing to you the method by which we're heat treating the specimens you're going to be using and go over the features of the electric furnace that is going to be heat treating the specimens. So one of the first things I wanted to point out is this, the process that we're going to be using is with an electric furnace. There are other methods by which you can heat treat specimens, such as liquid baths and stuff that are temperature controlled. There's other methods that introduce gases within the furnace chamber, but for this one we're just going to be using ambient air, just a simple setup just to get you guys introduced to the process. So the way I have the oven arranged, we have the tool steel specimens in the back, the spring steel specimens in the front, and you can see I have them conveniently arranged so it's easy to draw out of the oven, because when they are going to be pulled out, they're going to be at 900 C, and I have tongs here to demonstrate that we're going to fit them in there, and we need to have them easy to grab, first of all because they're going to be hot. We don't want to be juggling them when they're that hot. It would be dangerous, and right now I have bare hands and the tongs. But as you'll see when we come to pull them out, with everything being as hot as it is, I'm going to be having gloves with the tongs, and it can kind of get a little bit clumsy holding these. So we want to make the specimens easy to pull out so that we don't make any mistakes with them. You can see we have two in the back there that are going to stay there. Those are going to be the furnace cooled ones. We won't have to touch those. And that's pretty much it for the arrangement. So everything's been arranged. While things are cool, we don't have to worry about putting things in a hot oven. And I'll quickly go over the features of this oven here. You can see, because it's an electric furnace, we have electric coils on the sides. We want to make sure not to touch those when we have the tongs inside there, because they are exposed electrical wiring. We also have a thermocouple in the back that's measuring the temperature. And we have ceramic bricks that have been shaped and are holding the electric coils to keep everything well insulated. Moving on, we have the controller on the bottom, which is going to be showing, basically controlling the temperature within it's a control system controlling the temperature within the furnace. Right now I'm going to turn the machine on, and we'll set the thing, and we'll be coming back in 2 hours. You can see the set temperature here, 900 C is what it displayed. And we're just going to turn the machine on and close the oven. And we'll come back in 2 hours when the specimens have had sufficient time to warm up. We're going to let them sit 2 hours after the machine has reached 900 C, and that way they'll have enough time that we know that the specimens, with the size that they are, should be up to 900 C to do heat treatment of. Okay? That's it. Alright, we've had our specimen inside the oven for 2 hours now. They've had sufficient time to reach equilibrium temperature of 900 C. And as you see now, we'll start the heat treatment process and quenching them in two different liquids that we have, and also air-cooled and furnace-cooled. What I should point out before we begin, I have some safety equipment on. I have a long-sleeve shirt to make sure I don't have any skin exposed, so to protect me from the heat. Likewise, really thick gloves. And as I mentioned earlier in the video, we're going to be using the tongs to extract them. Also eye protection too, just to shield my eyes from any kind of stray objects that might fly or pop when the specimen hits the various liquids that they're going to be quenched in. So I'll get ready here, and we'll open it up and get started. The first specimen that we're going to be pulling out is going to be the air-cooled specimen, and for that I'm just going to pull it out of the oven and put it onto the plate where it will rest until it reaches ambient temperature. The next specimen I'm going to take out of the furnace and put inside the water, and I'm going to be stirring it around. Alright, our next specimen is going to be the specimen that's cooled off inside the oil. I'm going to be putting the specimen directly into the oil and holding it still there, where it'll cool off a little bit at a little bit slower rate than as stirring it around with. So now you have seen the heat treatment process from start to finish. You've seen at the beginning we arranged our oven while it was off, arranged the specimens inside there so that they're easy to grab. We put on our protective clothing, protective gear, grabbed the specimens and quenched it in various media. We have the oil, the water, and we had air-cooled and furnace-cooled. And as you will see in the lab report that you're going to be writing up, and from the different heat treatment methods, depending on how you quench it, you're going to affect a couple things in material properties. You're going to see that the ductility is going to change. You're going to see a specimen that's more ductile or more brittle. You're going to have different values of yield strength and ultimate tensile strength, and you'll also affect the hardness of the material. And we're going to prove through some testing, hopefully, for 3 specific specimens, the furnace-cooled, the water-cooled that's been stirred around, and the oil-cooled specimen. We're going to do simple impact testings to hopefully show that in general, for a slower cooling rate, you usually have more ductility than one that has been quenched faster. So hopefully that'll show in the testing, and that's what we'll do next. Okay, so we have our specimens already cooled off, and the next thing we're going to do is show an example of 3 specimens that we're going to break. And the way we're going to break them is we have a vise. You can see the specimens in the vise. And I have a hammer here, and you're going to see, we're going to do some very simplified impact testing with the hammer and the vise, and you're going to see how the response is for these 3 specimens. And the 3 different ones that we have are the furnace-cooled, the oil-cooled without stirring, and also the water-cooled that has been stirred. So you have different cooling rates, and we'll be able to see the different responses from them, and we'll see the impacting of them. Alright, so for the first specimen, and just like the other specimens we're going to be testing, I'm going to start off with hitting them slowly at first so you kind of get an idea of how softly I'm hitting them and work my way up to go firmer. And always make sure you wear eye protection.